Hi everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is meeting rooms 3 and it is a hard level problem. So the problem basically says that we have been given an integer n which basically denotes the rooms from 0 to n minus 1. Now we have been given a 2D integer array which is meetings, and meetings of I denotes the start and end time of a meeting. Now the meeting will be held during the half closed time interval. What do they mean by this? Half closed time interval basically means the meeting is going to start at this particular point, but it is going to end at this point, not including the last point. So basically end of I is not included. This is what they mean by half closed time interval. And all the values of start are unique basically, they're saying us. Now meetings are allocated to the rooms in the following manner. So these three conditions are important. Let me take a screenshot and then explain you. So these three conditions are basically denoting how rooms will be assigned to all the meetings, and at the end we have to figure out the meeting room which has the most number of meetings, right? So let us focus on the first condition. Each meeting will place in an unused room with the lowest number. So basically there will be some meeting rooms, right? Let's say this is 0, this is 1, this is 2. So whichever of them is free and has the lowest room value, that is this value, is going to be used first. Now if there are no rooms available, then the meeting will be delayed until a room becomes free, right? And it should have the same duration as the original meeting. So if you remember, in the initial array, we were given the starting and the ending time. You have to be very careful that this is not the duration of the meeting, this is just the ending time. So starting time and the ending time has been given to us. Now if a meeting is delayed, for example this was initially 4 and 7, that basically meant that the meeting will start at 4 and end at 7. Now let's say the meeting was delayed to some point, and let's say this meeting now started at 10. So at what time will my current meeting end then? As you can clearly see, this was a difference of 3. That means the duration of the meeting was 3. Here also the duration of the meeting should be 3, and that is why it should be 13, right? So the duration will be calculated by doing end time minus start time, right? That is what they mean by this particular second statement, that the duration should be the same, right? Now when a room becomes unused, the meetings that have an earlier original start time should be given that particular room. Now what does this condition signify? For example, there was a meeting starting at time 4 and ending at time 7. Similarly, a meeting started at time 5 and ended at time 10, right? Now let's say we have 3 rooms that are booked. All of them are booked. This one is going to be freed at 12. This is also 12. This is also 12. So basically I am denoting that these rooms are going to be available at time 12, right? Or even better, let me just take different values. So I'm just going to take different values here. So let's say this is 12, this is 15, this is 20, right? So that basically means room 0 will be free at time 12, room 1 will be free at time 15, room 2 will be free at time 20. Now if you see, at any time after 5, 6, 7, 8, 9, 10 and 11, at these times both of these meetings are getting delayed, right? Both of these meetings are inside the queue, but no room is available. At time 12, this room will become free, that is room 0. So now I have 2 meetings. Which one of them should I schedule in room 0? The answer is I should be scheduling the meeting with a lower start time. This is what they mean by the last statement. When a room becomes unused, meetings that have an earlier original start time should be given that particular room. That basically means meetings which were started earlier should be given the most preference. So at time 12, when both of these meetings were not assigned in room, I should take the first meeting and then assign it to the room 0. Right, this is what they mean by the third statement. I hope that these 3 statements were clear to you, and then we'll proceed to the next part. Now at the end we just have to return the room that has the most number of meetings. If multiple rooms, then the room with the lowest number should be our answer. Now they've also included the definition of the half closed interval, which I've already explained. So how do we actually solve this particular problem? I'm going to solve this problem with the help of a priority queue, which is internally implemented using heap in C++. So what information am I exactly going to store in my priority queue? I'm going to store a pair of integers. So a pair of integers. A pair has a first and as well as the second part. So what is this going to denote? The first part is going to denote the time at which my room will get free, and the room which will get free, right? So basically this pair collectively is denoting a room information. What is the room information? The second part is the room itself and the first part is the time at which my room will get free, right? So this is what I am storing inside my priority queue of pairs of integers. Now I want this particular information to be in the sorted order. By sorted order I mean, that means the time at which my room will get free should be in increasing order, as well as the room numbers should also be in increasing order, right? So what should I do? I should be maintaining a priority queue and this should be a min heap. By default, C++ would construct a max heap. Max heap basically means the value at the top will be the maximum, but I want a min heap, so if I construct a min heap, the value at the top will be the minimum value. So I want this first and second value to be as small as possible in the beginning. That is why I would use a min heap. So the way to construct a min heap in C++ is to write like this. So I would write priority queue. I would pass in the data structure that I want to store. I would pass in the vector of the data structure that I want to store. So vector of pair into int, and then I would pass greater pair int. So this would construct, or this would help me to form a priority queue, that is a min heap. Why? Because I wanted this first value and second value to be arranged in increasing order and I wanted the top value to be as small as possible. Once I have constructed this min heap, how would I initialize my values? So initially all the rooms will be free at time 0, right? So I would push 0, 1, 0, initially 0, then 0, 1, then 0, 2. What is this denoting? This is the time which at which my room will get free, and this is the room number. Room 1 will also get at time 0 free. Room 2 will also get free at time 0. This is what these three things are denoting. Now, this will be the top of the priority queue. This will be the second element in the priority queue. This will be the third element in the priority queue. You see, this is the exact order that I wanted. First of all, they are arranged in increasing order of their free time, and then they are arranged in increasing order of their room numbers, right? Now, once I have all this information combined, now I am going to traverse through my meetings array, which is given to me in the input. So let me just explain you with the help of an example. We're just going to consider, let's say, this first example only. So this is my input. I'm just going to copy it. The answer for this particular input is going to be 0. Let us see how it is coming out to be 0. So I have pasted the input here. Now initially, what is going to be my priority queue? My priority queue is going to be 0, 0 and 0, 1. Since there are only two meetings rooms, that is why I have two values here. Now I come to the first meeting. Its starting time is 0 and ending time is 10, right? Now my current time, let's say I am also maintaining a current time variable, so time is equal to 0. This is going to denote my current time. So at my current time is equal to 0, is there any meeting that has to be scheduled? Yes, that meeting is 0, right? Or the first meeting. Are there any rooms which are free at this particular point? Yes, there is this particular room that is free. So what I'm going to do is I'm going to assign the first meeting to the first room that we have in the priority queue and then push it back into the priority queue. So basically I'm going to remove this particular number. First of all, that means I had two meeting rooms. Now one meeting is assigned to the 0th room. Now since a meeting is assigned, now I have to change its free time. So when I change its free time is going to become 10. So now the priority queue will look something like this, right? So there were three things that happened. First of all, I realized that there is a meeting that has to be scheduled at time 0. I scheduled that meeting. In which room should I schedule? This was denoted by the element which was in the top of the priority queue. That was room 0. I scheduled the meeting and then incremented the value of room 0 by 1, denoting that one meeting was scheduled here. Now since a meeting was scheduled at room 0, I need to push it back into the priority queue by updating the time at which it will get free. Since the meeting started at 0 and will end at 10, I have to push 10, 0 into my priority queue, denoting that this particular room 0 will now get free at time 10, right? This is all the things that I did. Now I move on to the next value, that is 1, 5, and my time is also going to be 1 now, right? So now what I do here is I am going to check whether there is any room free. So this particular room got free at time 0, right? So that is not a problem. I can clearly use this particular room. How am I going to use it? I'm going to increment this value by 1. And since I'm going to use this particular room, I should be pushing this particular room back into my priority queue. So what is the time at which it will get free? That time is going to be 5 and the room number is 1. So you see, now the time has been updated and the room number remains the same. So this is the current status where my priority queue is denoting what are the rooms, what are their free times, and what is my current time is stored in a different variable, right? And this is the current status of my room or the meetings assigned. Now when the time becomes 2, I come to this particular value. Now it is going to start at 2 and going to end at 7. I need to pick a meeting room. I take the front element of the priority or the top element of the priority queue. I see that it was supposed to get free at time 5. I am saying it again. The current time is 2, but the top element of the queue is supposed to get freed at time 5. So what am I going to do? I am going to update my time to 5. You see that the current time is 2 and the closest element that is going to get free is element 5. So there is no point going through all the different values of time 3, 4 and all of these values in between. I can just directly jump to time 5 because I know before that no meeting room is going to get freed, right? So what I do, I just jump my time to 5 and then take this particular meeting room. I increment this value by 2, and since this meeting was delayed, the total time should have been 5. This was the duration of the meeting, that is 7 minus 2. But since now this particular meeting is starting at time 5 and it is going to continue till 5 duration. So that means when I push this particular element back into the priority queue, let me erase this. When I'm going to push it back, it is going to be 10, 1. Now you see this element is going to be after this element because the ending time is the same here, but the room number for the second element is greater, right? So I was able to maintain both of the conditions, that the ending time should be in increasing order as well as the room number should be in increasing order, right? So this is the current status of the queue. Now you see that this particular element or the room 0 is present at the first position. That means this element or the last meeting is going to be scheduled at room 0. Right. So this was the overview of the problem. Now there are a couple of more things that we need to discuss. So that particular thing is, let's say I'll have to construct a test case to explain you that particular thing. So let's say 0 was supposed to get free at, we have some meetings 0, 5 and then 1, 0, 10, 1, 5 and then let's say 15, right? 15 and then 20. So what will happen? Let's say I have 2 rooms, right? So what will happen is, let's say this was my first meeting and this is my second meeting, this is my third meeting. So my first meeting is going to start at 0 and end at 10. So the room 0 received a meeting and this is going to get incremented by 1. My priority queue currently will look something like this. So 0 and 1 and 10 and 0. So basically room 0 is going to get free at time 10 and room 1 is going to get free at time 0, which is already free right now. Now I come on to the second meeting. Now this particular meeting was assigned the second room and it is going to end at 5 time, right? So now this is going to get updated and it is going to be 5, 1. Now when I come to the third meeting, now you should be focusing on this particular part. So what happens is, the time is currently 15 when I am currently at the third meeting. The third meeting is going to start at time 15. Now by time 15, this meeting room will be free, that is room number 1, which was supposed to get free at time 5, as well as this meeting room will get free, which is room number 0 and it was supposed to get free at time 10. You see, both of the meeting rooms are free currently, but my priority queue structure is like this. That means the top element in my priority queue is this particular element or the room number 1. This should not be the case. Currently both of the rooms are free, so I should be picking room 0. But instead in my priority queue, my topmost element is the room number 1. So this could lead to wrong answer. A solution to this is, I maintain a second priority queue. So the first priority queue was storing this particular pair. The second priority queue will only store an integer, that is going to be the room number. Now the second priority queue or PQ2 is going to store all the room numbers, store rooms which are currently free, right? This is what my second priority queue is going to store. So you see, I've explained you a test case where our solution could have gone wrong. I'm explaining you this particular part again. This particular meeting was assigned to room 0. This particular meeting was assigned to room 1. At time 15, when the third meeting was supposed to start, the priority queue will look something like this, where the topmost element is 5,1 and then there is 10,0. Since you can see that the priority queue is sorted based on the first element, right? That is the free time. That is why the structure is supposed to be like this. This is not the ideal case. So what we will do, we will maintain a second priority queue which is only going to store the rooms. So at time 15, I am going to take out all the elements from this particular priority queue which was supposed to end at time less than equals to 15. Then among those, I can choose the smallest value with the help of this second priority queue. This is how we are going to fix our solution. Right. So let me just show you my final code, what I've done, and then the implementation will be much clear. So you can see I've taken a lot of long here. You can just ignore this long. I actually got a wrong answer due to overflow by using integers. That is why I have to take long. But this is very simple. I will explain you this particular part first. So what I've done, I've taken a priority queue of pairs, then I've taken a vector of pairs, and then I've taken a greater of pairs, right? Now, similarly, I've taken a second priority queue, which is basically long or the data type, and then I've taken a vector of long and then greater of long. Since I also wanted the second priority queue to be arranged in increasing order, that means I wanted it to a mean heap. That is why I have to pass all these parameters. I have sorted the meetings array because I was not sure that the meetings array will be sorted or not. I was not able to find it. So anyways, if it is already sorted, then well and good. If not, you will have to sort the meetings array so that the meetings are arranged in order of their starting time. Now I will initialize my answer with 0. This answer vector is basically going to denote what are the number of meetings that are being held inside each of these meeting rooms. Right. Now what I do, I am going to go through all the values of the meeting rooms and I am going to push 0, I inside my priority queue. Basically denoting that the ith meeting room is going to get free at time 0. Now I initialize my time with 0 and I am going through all the different meetings here. Now my time is going to be maximum of time meetings of I0. So this example I already discussed. What happens if I am currently at time 2 and the next meeting is supposed to be start at time 5. So there is no point in iterating through all those time values, and that is why I can just directly jump to that starting time. Now while my priority queue has some elements and my current time is greater than or equals to pq.top.first. So pq.top is basically denoting the first room that will get freed and the first is denoting the free time. Right. So while my time is greater than or equals to the time the meeting room was supposed to get free, that means this particular room can be used to assign another meeting, and that is why I push it into my second priority queue, the room number, right? So the room number is getting pushed into the second priority queue and the value is popped from the main priority queue. Now let's say even after we did all of this, right, my second priority queue is still empty. Now which is this particular case? This is going to be the case when my all rooms are busy and it is going to get freed at some time later in the future. So what I do, I just directly jump to that particular time by going to pq.top.first. So this is the first time at which at least one of the rooms will get free. None of the rooms are free. That is why I had to jump to that particular time, and then I do the same thing that I did here, the same while loop I implemented here. Now this will make sure that my second priority queue will have at least one element, right? So I just take that particular element. So meet is basically the meeting room, and I just pop it from the second priority queue. I increment the answer of meet and I push into my main priority queue the current time plus the duration. So meetings of I1 is the ending time, meetings of I0 is the starting time. This is their difference is going to be the duration. I push it into my priority queue as well as the room number, right? So this is the time this particular room will get free and this is the room number itself. At the end, what I do, I just initialize my room and max with 0. I'm just going through all the values. If answer of I is greater than my maximum value, then I'm going to update my maximum as answer and room number as I. At the end, I can just return my room and this would be the final solution. So let me just quickly submit this and show you that this particular code works and the solution is absolutely correct. So you see, this passes all the test cases and is a good enough solution by the time complexity. So I hope that you guys were able to understand the solution, and if you guys did, then consider dropping a like on this video. Don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.